It did, but they used to start now.
Oh gosh. Minor details. Okay, I'm sorry.
I don't want to, I prefer not to ambush you with this point. This is so we got the 3x3 matrix here, but we said when we have the scalability column, it's a 3x4 matrix. And the column that's missing here, which is what I noticed, is this column, the accuracy column. And in the graph, there's a metric between reported rate, the asynchronous message processing rate, but it also has the loss ratio measured at these rates.
Yeah.
And so what we've actually got here is, instead of this table, which is a single table of results at each iteration of the test, and then an average at the bottom, what we've actually got here is a two-dimensional here, where you can plot the asynchronous message processing rate and the loss rate. And I think we need to do that because all of the previous tools, like Cbench and Wrapped Cbench, and other things that are of the same ilk, they went on to report a maximum rate which was independent of the loss rate. So we're actually introducing this new dimension here, and it's incredibly important because for some reason people thought, and you know how this stuff works, you get a packet that you haven't seen before from plugins, and they send that packet in with control. If that message doesn't get responded to, the flow is sitting there waiting, and that may time out, and eventually the switch sends a read request. But that takes another second. And when you use it, it's going to look like you're having a pivot. If you're operating the switch where the loss ratio is 10%, 20% operators,
Yeah, of course.
we got to be operating down at a sort of a zero loss rate maximum. So I think it's important to report both so that we've got capability with the old tools that to take a stand that we want to be reporting the loss ratio that is at zero loss rate. And maybe what's needed is a sort of the loss ratio kind of is embedded in this definition.
No, so go back. This is where this part was matrix. This was supposed to be the number of messages that quickly were dropping, which means ostensibly the loss ratio is zero.
Right.
So I didn't notice that loss ratio made it in because I already had that out.
Okay.
If the objective is that you're going to do it without dropping, then I think by definition you can report loss rates. But the point of it is supposed to be that you're reporting a number where the loss ratio number effectively is zero.
And so I'm saying in order to have a bridge to the way this used to be measured without taking loss ratio into account, we ought to be reporting both in the XY because people are going to measure this way and this is a lot lower than what I used to be able to see bench or something. What's up with that? And if we've got the comparison between the maximum like an RC 2889 and maximum frame rate, they have a maximum frame rate and a maximum frame rate at zero loss or something like that. So they actually report two levels of this. And I think
You're asking for a second rule on tablets test. You have a second one where you're setting some number of packets and also recording your loss ratio.
It's the same procedure. You just have two metrics.
Well, yeah, one explicitly has an implicit zero, the other has an
Yeah.
explicitly being recorded.
That's right.
Sure. I don't think that's going to be controversial. It probably solves the fighting arguments.
Yeah. The original definition didn't take into account loss ratio. And this is what I discovered as part of the C-Plan problem. Okay. Everybody's reported this value that it's actually meaningless. Because the loss ratio is, I finally saw some measurements, and the loss ratio is like 10% or something, but at the maximum frame rate. So, no good.
Yeah.
So let's fix this.
Okay.
And I think it, like I said, I think it involves also putting accuracy in here and having the
Loss ratio.
loss ratio be, actually, the loss ratio applies next to this one. I send you this message, processing loss ratio.
Yeah.
Okay?
Okay.
So that's a heads up. We can discuss it further. It's probably good to discuss it with you too. There's just a few more.
Okay. Thank you.
Good. Okay, I guess we can get going here. I hope that more people find this.
Okay.
When somebody remote, I'm not quite sure. I think more and more people on the room. So let's just hold off a couple minutes.
Before we get started, we wanted to let you know that the folks who sit at the back rows, you are automatic note takers and jabber scribes. And if you would like not to be, we suggest you move forward.
Although we do understand the constraint of power for your computer, so there's not a lot of jackets in front here.
I see an open power strip right in the front row.
Yeah, that's right. Actually, there's a whole bunch right underneath our AP advisor there.
And Warren's not known to bite
Right.
much, yes.
I'll start the blue sheet around. Do you have a spare piece of paper or something I can take notes on? If not, I will just rip off the back page of that other blue sheet there. Thank you. Use it.
I'm gonna keep a little bit of notes.
Mm. None of this is oh, thanks. Hey, we're just going to wait another minute or so, and then take notes
Oh, on the blue
on
sheet.
the blue sheet. This is good enough. I've already ripped it off.
I will go and find them, paper.
Yeah, we'll steal a page from
The
somebody
next
else.
working group?
And they can steal one from the next working group.
Do we have anything to do in JavaScript?
No, not yet. But is anybody monitoring Jabber? It's still blocked for me. Otherwise, I would try. Yeah, the corporate. Yeah, yeah. Find yours. Keep it out. Let's go. Good morning, everybody. This is, as you can see, this is the benchmarking methodology working group session. One of the first sessions here at IETF. We're your co-chairs. I'm Al Morton, and this is Sarah Banks to my right. And this is our working group meeting for IETF 99. If you're not subscribed to the mailing list and you'd like to do so, you can grab these slides and click that link and join us on the mailing list. How many people are attending Bmwg for the first time? Quite a few, about 7 or 8. Very good. So welcome. You'll find that this is a really easy group to join if you have some testing background. And there's not that much literature that is absolutely necessary to be able to have read and to join our discussions. A few RFCs you'll see and hear as frequent references, and those are the ones that you kind of start out with to get a good background in this. And, and actually come and talk to either one of us afterward if you want a list of 3 or 4 things that are not bad to read to start. And we're in the process here of developing benchmarking methodologies, which is benchmark metrics and laboratory procedures for measuring the important performance characteristics of network devices. So welcome to our work. Let's see if the clicker works. Okay. All right, so since this is the first session of IETF 99, it's important to go over this note well with a little more care. So essentially what we have is several documents here that describe the, is this going to turn me later? Oh, yes, okay. So we have several documents here that describe the rules for IPR disclosure regarding contributions to the IETF. And contributions are oral statements or written or electronic communication made at any time or any place which are addressed to all of these bodies, i.e. IETF plenary, IESG, any IETF mailing list, any working group, which we are right now, any BOF, birds of a feather session, the IAB, the RFC editor, and all the contributions are subject to RFC 5378 and 3979, updated by 4878. So we basically ask that everyone be aware of these things, and when you registered for the meeting, you checked the box that said you were aware, and as a result, so we're expecting everyone to follow the rules documented there. And what does it mean? Essentially, if you have intellectual property or know of intellectual property associated with a statement that is a contribution, as I've just qualified it, then you need to disclose that IPR in a timely fashion. And that's all we ask. Okay. Everyone understand? I see a lot of nodding. That's good. And smiles even. That's good too. Excellent. All right. So on to the real work. So here's our agenda. I'll quickly ask for volunteers as a note taker. Volunteers? Okay. Marius, thank you. And anybody else? We usually try to get two. So that while one note taker is speaking, another can help out. Anybody else want to volunteer? All right. Well, we'll hope to get some help with that. And in fact, feel free to join the Etherpad. The details of which I can't easily provide you because my PC is locked up here, but we can get that going. So here's our plan. We still don't have a Jabber scribe, right? Oh, okay. Sarah's going to take care of jabbering. We've talked about IPR. The blue sheets are circulating. And Kiki, I noticed you need to sign the blue sheet, please. So it's right up front here. Just and try to keep the sheet in the back. And if anybody walks in the door, hand it to them and suggest that they do as all the rest of us have done and sign it. And that would be great. All right, so here's our agenda. We're first going to talk about the working group drafts and the status of the working group. Briefly talk about our charter and milestones, and then we'll go into the working group drafts, of which right now, as I'll mention, only 2 are left on our charter. So that's a good thing. But it leads us to a recharting discussion, which I put on the diagram here. Yes, okay, it is there. I forgot to reorder these in the online agenda, so that's okay. I'll fix that later. All right, good. I was sort of thinking about that, but I didn't realize I did it on the slide. Good. So then we have a draft which is sort of on its way to working group adoption. I think that's the best way to describe it. We had good support at the last meeting for adopting it. We had many people say on the mailing list that they would support it, but only a few said that they would actually review the document when I reminded people that that's a part of supporting the document. Writing one word in an email reply, support, that doesn't get it over the edge. We really need, the truth is, we need expertise in these areas to be able to complete the work in a manner that's going to be useful to the industry. So that's the kind of thing we're looking for to be demonstrated in the review comments. And so when you say that you support a draft and you reviewed it and you have this question about it, that's how you demonstrate that expertise. So we've got that draft and it is moving forward toward adoption. I guess that's the best way to put it. Now, then we've got several other drafts which have been proposed. One on service function chaining. Keiki Kim is here to present that. And then we had this other one, considerations for benchmarking network virtualization platforms in the data center environment. And that's unfortunately going to be wiped off the agenda today. The presenters weren't able to join us, and there hasn't been an update on the draft either. But we did have an excellent discussion of this in Chicago, so I was hoping that they would come through and join us. So then after the drafts that we discussed today, we'll have a rechartering discussion. And we'll kind of put down our ideas and get some feedback from the group, and then discuss a schedule for rechartering, because we have very nearly completed all of our chartered work items, and that's a good thing. The question is, do we have enough work to continue? And I mean, personally, I think the answer is yes. So then the final thing we'll do today, and this is the kind of thing that we've been able to do a little bit when we have a long session like this, is to take a look at some related presentations and topics from other organizations. For example, last summer we heard from a software-based traffic generator design team, the Bmwg traffic generator. They were here with the Advanced Network Research Workshop last year, and then stayed on to give our group a good talk about this Bmwg traffic generator. And then we also heard from the FDIO continuous integration and testing team, and the kind of work that they were doing to test the Cisco, now the FDIO open source VPP virtual switch. So this year, what we're going to hear is a talk about the OPNFV VSPerf, that's the vSwitch performance project in the open platform for NFV. We'll hear about benchmarking results, test results actually from that project. We've heard about the project here many times because that group made contributions to our work in the area of sort of test setups and configuration parameters for repeatability. And now we're going to hear a bit about what they've done with recent testing and the results that they've collected. And there are, of course, implications on our future work, and I'll try to emphasize that as I go through it. So as you can see, I have my OPNFV Summit T-shirt on today, and so in that particular talk, I'll be representing our project work with my two co-authors. And then we'll have any other business at the end. So any questions about the agenda? Any bashing to take place? Seems not. Okay. So let's move ahead then. All right. So here's the quick working group status. And this is why we're rechartering. We've got IESG approval on the VSPerf, that's the OPNFV project I just mentioned, the vSwitch draft. So we've got that just accomplished a few weeks ago. We also got IESG approval on the IPv6 transition technologies draft. And they were actually going through the IESG the same week, which made it very interesting. lots of traffic on our list. And then most recently, we've gotten IESG approval of the data center benchmarking drafts, which were working here for quite a while. And that caused a lot of commentary and additional feedback. So, and now the working group is really seeing all this feedback. It's really quite extensive, and it informs us in ways that we need to know in order to get our drafts through more efficiently. So it's good to read the kind of feedback we get from the IESG members in this final stage of the group. And as I pointed out, the talk, both the major talks we have today are new work proposals. They keep coming, and I'm sure we'll see some more. So additionally, we have two new RFCs that were announced in the interim period. We have RFC 8161 on IPv6 neighbor discovery. I'm sorry, that's what ND stands for there. I should have probably spelled that out. But we have a draft on benchmarking that, and the very next one that's going to be announced, probably sometime today, I would guess, or this week at least, is 8172 on the VNF virtual network function and NFV network function virtualization infrastructure benchmarking considerations. This was the first step in our working group charter pivot to begin to take on the benchmarking of virtualized network functions, and which was a key step in our rechartering activity the last time around. We've previously done a benchmarking of physical network devices with their dedicated hardware, but now we're expanding our focus into this virtual network function and their infrastructure benchmark. So this was first step, and glad to get that complete. If you're beginning to work in this area, this is an excellent draft, I think, to take a look at. There's a lot of good working group considerations and contributions there to consider as we begin this topic together. So we'll have a discussion of rechartering. That's our charter update discussion. And very soon, we'll have our supplemental Bmwg page announced. Sarah's been working on that and has created the place where we'll sort of keep our interesting information about, for people who haven't been able to attend a meeting, the kinds of things that I said when we got going here, how easy it is to join the group and what you need to do first and second and third, things of that nature. And in the past, we've included reviews of particular documents there and analysis of comparisons and so forth. So it's been useful to have our own supplemental page. And unfortunately, Comcast decided that they no longer provided web pages for residential customers. So that's why the old web page is gone, and we're going to get a new site for the web page of the future. So that was kind of a surprise. They do it for small business customers, but oh well, not me. So here's the quick status on the milestones, and yeah, so we've only got one left. Isn't that cool? And it's actually, it's intended for this month, and well, we'll certainly have that, and we'll work on the various comments that we just talked about together. But we're really close to completing everything that was on our charter, and that's why we're going to have this rechartering discussion. So I think I will hold up the presentation there and ask if there's any questions about the status of the working group or our current work. No? Good. Okay. So so yeah, this is it's been a very successful last year or so in getting all of these drafts moved forward, and that helps us to make space on our attention span and our working group agendas to be able to adopt some new work now. And that's why we're beginning to consider these things in earnest. So let me bring up the agenda here. This okay. So I think our first item on the agenda is to talk about our last working group item, a set of two drafts that constitute benchmarking methodology for SDN controller performance. And we've been working this for a while. Sarah is one of the co-authors on this work, and so I'll turn it over to you, Sarah, to give us the stats.
So with feedback from Al, the last time this went out for working group last call, there were some comments that came in. Those were addressed. When we uploaded the draft, Al caught something that maybe I should have, which was, hey, it's not clean. When I do reviews for Ops Directorate, I'm usually the first one to pick out on nits. So I found it very ironic that
it's an easy step to skip.
That Al was like, your nits are totally dirty, and they really were. I think there were like 14 or 15 issues there. So in any event, we've gone back through and cleaned up those nits. That was, I believe, submitted 2 weeks ago now, so it was under the deadline. And so at this point, I think we're looking or asking the working group to do another working group last call. It's been a long time coming. This draft has been thoroughly reviewed and worked on for quite some time. So if you're new, you might be wondering, wait, what? It's going to working group last call, but it's been around for some time. It's gone through a working group last call, and we're kind of at the end of that process now. It's kind of how I feel about it.
Sure. So and first off, any comments from the attendees about this SDN controller benchmarking work? Okay. Well, so as I mentioned to Sarah before, I have a couple of comments, and one of those is related to one of the drafts that we've just got approved and basically all the way through the publication process. And that is the considerations for benchmarking BNFs and related infrastructure. This will be the RFC 8172 as soon as the editors announce it. Everyone's now satisfied with what we've got there, including the editors. So when I was looking at this particular section in that draft, I was looking at let's see, where did I cite this? Well, I won't try to find that now, but there are actually two drafts in the working group which have sort of embraced this matrix for organizing and evaluating the benchmark metric coverage that's provided in the draft. And the way this matrix works is this. We have these different phases of communication listed in the first column. It's activation, operation, and deactivation. So you can kind of think of like setting up a path, evaluating the performance of that path in terms of its throughput, transmission rate, latency, loss ratio, and reliability aspects of that path. So we're going to activate the path, and how long does it take? Does it get activated accurately? Is the activation reliable when it's repeated multiple times? So these are the kinds of things and areas that we could be benchmarking, and it's important that almost all of the cells of this matrix are covered by benchmarks or performance metrics. And what we learned in the process of applying this to benchmarking is that in fact we needed an additional column here, one that measures the scalability of the size of the devices and the network functions that we're benchmarking. So how many sessions can a device support, and how many switches can a controller control? These are scalability aspects that needed to be represented in the matrix in a way that we didn't have to worry about before. So when it comes to evaluating coverage, what we actually have is as I mentioned somewhere here, is a 3x4 matrix where we have scalability out here as the additional column. But this was the matrix that comes from an ANSI standard, ANSI X3.102, and it was originally designed for data communications evaluation back in a long time ago, back in the 80s. But it's been very effective to apply it to our work here, and we've done that now in two drafts: the SDN controller draft, and also in the VS perf contributions from OPNFD into our work here. We evaluated all the different tests that the VS perf project has designed. So in making sure that these citations were correct, I looked into the controller performance draft, and this is one of Sarah's drafts that she's just discussed here. And in fact, what I noticed was that the accuracy column was missing. And I originally thought that was just a synchronization issue between, this is the terminology draft where the benchmarks and other terms are carefully defined, and then the draft on methodology, and that's what this one is. So here's the section in Sarah and her author team's draft on controller asynchronous message processing rate. So imagine a case here now where you have many switches connected to a controller, and they all have an association with the controller where the controller is going to accept their request to establish a flow, and then to give back the information necessary to insert in their flow table to be able to accommodate that flow in the future on a switch-by-switch basis. So as a flow enters the network that's controlled by the controller, it's going to see many of these packet-in messages, and it's important to know for a given number of switches how many of these flow requests or packet-in the open flow parlance can they accommodate. But one of the things we learned in the process of this is that many of the original controller benchmarking tools didn't pay attention to packet-in, which is like a flow update request, message loss ratio. If a request came in and it was dropped or not honored, then a flow would be sitting there wanting to continue to send packets, but no way to do it. And that's that's really bad for network operators. But yet that somehow was overlooked. So so we've added that aspect to our definitions, and it's kind of like if you have a background in this work, it's kind of like the zero loss ratio throughput level, which we characterize in RC 2544. But then in the full mesh LAN switch characterization, RC 2889, we have a maximum flow rate there, which is independent of the loss. So there's really two kinds of parameters here, and the point was to try to capture both of them here. The old benchmarking tools have typically characterized the maximum message processing rate, but what we'd like to add, and we've begun to do that based on comments here, is to characterize the rate where there's no message dropping, so a zero loss ratio, and that's always going to be less than the maximum with frame dropping. There could be as much as 10% or 20% frame packet-in request drop rate at these maximum rates, and that's really unsustainable in an active network. You can't have 20% of your flows just sitting there unserved. That would be horrible. So we want to make that distinction, but we want to have the maximum so that there's kind of a correlation with what the old tools used to measure, and now we can clearly indicate the value of this new metric. So I'm suggesting that we go back and add the accuracy column here, and then pick up what would be this measured loss ratio, and kind of plot that in a two-dimensional form, so that you'd have the offered rates and the loss ratios and the achieved asynchronous message rate that the controller can provide. So that's the feedback that I've given today, based on sort of the comparison of a draft that we were just finishing up with the RFC editor and this one. And I'm sorry that it's taken a bit long to get that all in one place here, Sarah, and to your other authors. But I think it's good feedback. So thanks for accepting it. So that's the kind of interactions we have here. Right now, I'm sorry, it's only been between the two of us. And I'm hoping that more people will be more engaged when we get more detailed presentations of some of the further drafts as we go along here today. But obviously, feel free to come to the microphone, and when you come to the mic, please say your name first. That way we've got a good identification. I mean, that's one of our rules here. I think there's a sign on the microphone that reminds you.
Yeah, it's pretty clear. Okay, this is Marius. I just wanted to say that, I think the authors took into account my feedback, and I'm satisfied with that. So, well done for that. That's just that. Thank you.
That's great. Thanks very much. So we'll start the working group last call shortly after this meeting.
Yeah, why don't we,
And we'll include this.
I would like to, that way it's ready to go when it goes into working group last call. It's
as clean as it can be going in. How about that?
Oh, so you'd prefer to make the changes and then do the working group last call?
Yeah, I think they're really good changes. I don't think the other authors are going to have an issue with this, so I think it's minor to add it, but especially if we have new folks reviewing, I think it's a lot cleaner to go
Okay.
in with a clean draft.
Yeah, fine.
It'll only take a day or two, and we'll upload.
Okay. Okay. And since we're in the same location, if you want to be sure that we've fully understood each other this time, let's talk about it if we can.
Thank you.
Good. All right. Great. Okay, so we'll have a working group last call after the next revision of this draft. That's the way we'll capture that. Very good. Okay. By the way, was all this text up here fairly visible to folks? Big enough to see? Okay. All right. I see some people in the back of the room nodding. That's mostly what I wanted. Thank you. Sorry for the eye test if not. Okay. Oh yeah. So my agenda's here, I think still. All right. So our next next item is this draft on benchmarking methodology for Ethernet VPNs and provider backbone eVPNs. Sudine Jacob is here from Juniper, and we have a related draft here that's gone through many iterations. Sudine, I invite you to come up and make your presentation of the latest work here.
You have I mailed you the PPT.
Pardon?
I mailed you the presentation.
Oh yeah, I've got it. Yeah, you don't need your laptop. I'll bring it up here.
Oh, perfect.
Yeah. Yeah, you can have the clicker then. Yeah. Let's see how this is going to work. Good. Well, the price is going up. It used to be a beer.
Oh, yes, yeah.
Thanks for the beer.
Yeah, hi. Yeah, good morning, everyone. This is benchmarking on eVPN and PBB eVPN. This is the new RFC which came year and a half back. So this was is a new RFC 7623. So this is it's now it's widely deployed in the provider arena, and the main feature of this eVPN is like you can have both routers in the forwarding compared to VPLS, because you have to run either spanning tree or work as active and standby. Here both links can be utilized. So what all the money you pay it, that you will get the maximum benefit. That's the main main features. Like compared to VPLS, the eVPN become a big hit and people are deploying it with various flavors of eVPN. So which I explained. Yeah, the comments, it was from the last IETF, it was they want type 5 routes, because type 5 route was not a part of RFC, which came as a separate draft, because there are a lot of drafts which is going in best working group, which is it's like a vanilla feature. eVPN and PBB eVPN is like a two RFC's vanilla features. They add a lot of other things, like say for example they want to run VPWS over eVPN, E3, ELAN, kind of different services. So they spin off a new draft. So actually this was type 5 route itself is a draft which is adopted by the IETF best working group. So they want that also to be benchmarked as part of eVPN when we benchmark eVPN. So they ask, okay, why can't you do that? So I incorporated that as one of the parameters to, because we have defined the parameter. So now the problem is eVPN is implemented by different providers, and it is very difficult when you the test community, as well as when you buy this product or the services rented by different vendors. So you have to have apples to apple comparison. So you don't know, okay, say vendor X or service provider X is giving this. So how I rate it, there should be some standard, there should be some yardstick or parameters have to be measured. So that's how the motivation behind this draft. And type 5 route was the ask in last IETF. So we incorporate that as one of the parameters. So this is the test setup because the DUT is one of the multi-home PE. This is a typical EVPN deployed scenario. So because it will be active because that is the most deployed scenarios where active because that is where both routers will be forwarding the traffic. Unlike in VPLS, one will be active and one will be standby. So the load balancing will not happen from the remote routers in VPLS. But here, that is one of the aliasing is one of the key feature which we can say.
Sorry, one quick comment.
Please.
Where is the receiver in that diagram?
Yeah,
There's no receiver.
I was wondering the same thing. And Marius, don't forget to say your name, Marius.
Yeah, sorry, Marius. This is Marius.
This is the traffic generator. We will be sending the traffic and
There's two senders. Like, which
the
machine is receiving?
Customer edge device is where.
So the measurements are well reported by one of the machines under test.
Yeah, the performance will be measured because in this network DUT will be put there, and in this DUT we are running the sort of test and the reports we will be getting it.
Well,
So that will be treated as a black box.
So to be clear, you were saying there's only one device under test, and it is the DUT that he's noting, and not the CE or R1 that you have at the top of the diagram? Sudin? Is that what you're saying?
The DUT is where we have to have in test scenario. We have to have a DUT wherein you run the test and you measure the parameters. But to place the DUT, you need to have the other elements, network elements there, and the traffic which is pumping bidirectional traffic or unidirectional traffic which is pumping. That's why we written two RT ports or the router tester like IXIA or Spirent will be there. So the DUT is where is the reference point. The benchmarking reference or the viewfinder will be pointing towards the DUT.
okay, I think that should be clarified. It's not very obvious from the draft that that's the case.
It's mentioned there in that test setup. Clearly mentioned that the reference point which is mentioned and the traffic is pumped from unidirectional or bidirectional. The traffic is sent and the frame rate. All the details have clearly. I think someone raised two IETF back, so we have added all those points, the frame rate and all those things which have clearly mentioned. This layer 2 frames we are doing it.
So I've looked at the procedure as well. It's not clear to me. I'm just saying it's not clear.
Sure.
What do you do with that feedback? That's your.
Sure. I'll add it.
I understand that for you it's clear. I'm just saying that for me it's not.
Okay. No, actually that's what in that section test setup it was mentioned there. I mean, is that the reference? So in that the question came. So we added explicitly. This is where it is like that. We added that. If that is not clarified, we will once again look into it and we'll definitely look into it because that is where test setup in that is explanation is given and all that.
Yeah, because usually the device or the device under test or part of the maybe it should be, I don't know, put the frame, like one of the solutions I can think of, just like a frame around anything that's anything aside the DUT should be, well, a box that says tester, like, and then like explain that the tester is a multitude of machines like router 1, RRP, CE, and MPHP. So that's how I would kind of try to take care of it, because otherwise it's really confusing. You have two sender, like two traffic generators, and RFC 2544, which is like
that's about RFC 25. It's a frame which is sending the same methodology we incorporate.
Yeah, but I'm just saying that the clarity in that in that test setup should kind of be similar to what you're describing here. It should be clear what the tester is, what's the device under test. That's so it's like kind of an overview comment.
So to add to that, I think, Sudin, a couple of things. Having your R1 and your CE1/tester, right? I think a lot of us, when we see multiple routers on a diagram, I think we instinctively think those are all being tested. And
sorry.
And I see your point, it's not, but I also see Marius's point, and I think we talked a little bit about that yesterday. Reading back through the draft with your test hat on, with fresh eyes, and I realize that can be a little
Yep.
harder when you're the author, but reading back through and say, okay, if I
understand.
was going to go sit down and test this, does this make sense? And I suspect you'll get a little more appreciation for what Marius is saying.
Yes.
I find it a
so
little confusing
you
too.
the clarity. I mean, you want to have a clear demarcation, like
Yeah,
what
exactly.
definitely
That's
that's a point. It's noted. So if that setup, test setup, and the duty details, we will make it more explicit with bullet points in that.
okay. Thank you.
Thanks, Marius. We'll definitely appreciate your points. Can I? I think so. I can move to the next. Right? Yeah. Thank you. So these are the parameters which we defined it. These are the parameters like for the EVPN, the basic EVPN. The RFC is for like the Mac learning, Mac flush, Mac aging, high availability. Then ARP and ND scaling, because there's a Mac plus IP concept in that RFC 7623, the EVPN. Then the latest addition, that's a type 5 route scale, the scale, convergence, and the usual testers like we do is a soak test. So it's the Mac learning. What we do is like there are different types. The local learning, remote learning, and that is when the Mac is sent from one direction, then that is a local learning. Then the Mac is coming from the remote router. The time take to learn the certain amount of Macs, that, and when you are sending the bidirection traffic, and what is the amount of time, and this is repeated in interval, and it is plotted, because these Macs are advertised by BGP. It's unlike VPLS, it's a data plane learning, but here is the MAC details is advertised to other routers as a type 2 route, because they have defined certain NLRIs in EVPN.
So, Subin,
Yeah, please.
so on this diagram, you've got learn local and advertise to remote peer.
Yeah.
On your test diagram, can you show me how the packets would flow?
Yeah.
For those two cases?
Yeah, the packet is the local traffic will be the C. It is like a bridge actually. That will be a bridge.
That will be a bridge.
Yeah, that will be a bridge. Oops, yeah, sure.
I think it's like very complex.
The red one, yeah.
Wow, thank you. Yeah, actually, this will be a Lato bridge. The traffic, the local learning is the traffic which is bridged from here and reaching here, the DUT. Because it's a multi-home scenario, the traffic will be reaching here. So the traffic will be reaching here. The time taken to learn the local MACs and the time taken to advertise to this remote router. Because the local learning, it will be in the CAM table or the local MAC table. From there, it has to give to the BGP, and BGP has to advertise. That depends on how fast the BGP update goes and all. So that is where the delta comes into picture. The learning and the advertising rate will be different. You learn in the MAC table, which we follow the previous RFC, which explained about how the MAC has to be learned. That methodology we use, and the advertisement is from how frequent from the BGP advertisement, how long it will take to advertise that n number of MACs or x number of MACs to R1. So I hope.
So that's good for local. Give me the next one, the remote.
Yeah. Remote is from that traffic is sent directly to R1 because it's connected directly to R1. So the R1 it will be learn the MAC and advertised to here. So the same thing, reverse path will be applicable here. The local the MACs in R1 will be advertised as a BGP. So it will be coming as a BGP advertisement here. Then if from the EVPN database, it will be populating to the local path.
Okay.
So there is the R1 has to advertise. There is time differences there. Then the BGP advertisement comes here. Then from the from the BGP advertisement to program the actual table. So that's where the
So then the fundamental answer to the question, which I think Marius was raising, is that really all we need to do in order to accomplish MAC learning is to generate packets with MACs that need to be learned. And then to measure the benchmarks, we're going to be looking at the control plane interactions between the devices in your setup in order to determine when a MAC's been learned and when it's been advertised in BGP. Is that correct?
Yeah, that's the same we are doing it because
All right.
the BGP itself, it has serialization delay. Then the NLRI, the pack, as per the RFC, it has to hook up and send it. So that is where the actual benchmarking has to come. How fast the device, like various vendors' device, how it has to work. So
Great.
that's where, as a tester, this is one of the parameter which.
Very good.
Yes, sir. Please.
Jimmy Tower, AT&T. To echo what Al said, I was a little confused. So the benchmarking is from the DUT to R1 bidirectional advertisement of the type 2 route MAC/IP.
This test is first I'm discussing about the MAC. So the DUT is the reference point. So I'm keeping the DUT as a reference point, Jim. So you have the local learning, which is there, and the remote routes, which is coming from the R1. I have to populate to my MAC table because that is coming as a type 2 route. Because R1 will be advertising to the DUT as a type 2 route. Then I have to receive that routes. Then I have to put it in the MAC table. So how fast I have, say, for example, Nmax, how fast it is receiving
So
that?
I guess where I'm confused is I'm going the other way. CE1 generates traffic to DUT. DUT sends a type 2 advertisement to R1.
Correct.
Okay. So what I was sort of saying was the benchmark you're doing here is between DUT and R1 and MHPE2, because those are where that's your control plane.
Yeah, control
setup,
plane. Yes.
right?
Yeah.
Okay.
That's a control plane which is going.
So one other comment about this, in a multi-homing active-active environment, you may never get a MAC advertisement from MHPE2, just the ESI advertisement that is equal to the one on the DUT.
Yeah. This.
So when you benchmark and say how quick, this is where if you remove the ESI from MHPE2, you invalidate all the MACs at R1 that have been left from DUT. So it's not, it's possible you won't get the MAC advertisement, the type 2 from both.
Yeah. If it is, yeah, you are correct. Because this is also advertising for the local MAC. There is one way we can do is like make it a single active. So all the MACs will come to here.
Right, I was saying, so yeah, in an active backup scenario, that would be.
So all the MACs, say Nmax,
Right.
say, correct.
But in that way, it's quick. That's why we
Quick.
made it fast. We made it fast just sending
Sending
the
to.
ESI, the ESI advertiser saying invalidate everything that's associated with the CSI.
So if it takes active cycle, so this will be the active. So
Right.
all the MACs will be going here.
Right.
In active, I agree with you because this is also will advertise because load balancing will happen. This will advertise as a type 2 over here. That is also a delta is there. But local MAC, the what we define is this will be the standby. If you make it, then we can run all the MACs here.
Absolutely.
That is all the max Nmax because otherwise it will load balance. It will be the measuring won't be accurate.
Right. All I was saying was that when you measure, what you're measuring is the advertisement of the withdrawal of the ESI and the invalidation of all the MACs, such that you now center them on MHPE2 in an active backup scenario.
That ESI withdrawal, we are not benchmark it. It's a learning in the learning rate. That you
That's
can
it.
as a one of the trigger benchmarking. We had there's a learning rate. Bringing back the ESI. So withdrawal type 4 withdrawal comes and that is not not there because this is a learning. It's a vanilla test. So it's not a trigger. So that is not added. ESI withdrawal is not added.
So ESI withdrawal is an optimization to make
Yeah.
it much faster than you would if you had to invalidate every MAC upon learning of the MAC withdrawal.
So if type 4 withdrawal immediately, then the type 1 out to the remote, this one, yeah. We'll look into it.
So Sudhin, what I'm hearing is carrier feedback that maybe you should consider the withdrawal scenario, and I think you should also explicitly consider active-active and non-active-active in both scenarios, because I hear you, this is about learning, but there is no learning without withdrawal. At the end of the day anyways, I agree that learning might be its own discrete test, but I think having withdrawal is also very important to measure. There's never been we all do it anyways when we're out testing for as vendors, we all do it for our customers. They're
Correct.
asking us for it anyways. So to have the draft without that, in my opinion, it's lacking. So I really hope you would consider adding both scenarios.
I mean, just from a carrier perspective, So
Yeah,
when
Jim,
a new customer comes on, you learn something, they're not unhappy because they're just coming on.
Exactly.
Okay.
Now, when something goes down and they're out for a certain amount of time, then they're unhappy.
Exactly.
So we have to, so you should look, when you benchmark it, you should add that, that should be the primary thing.
That is, Jim, actually, we added that as a link because normally in provider, the link failures is frequent. So we added that link failure, local and remote, which is added that for benchmarking because ESI withdrawal, because what we have done is a link, what we have added as a parameter is like a link, the failure. That is where the MAC flush is a parameter. Next I'm coming to that. The local failure, that means is as good as ESI failure. The local as well as remote. So how fast is it is getting flash? So that is covered actually. That's called MAC flash. That is the link failure. We are simulating it. That I can come to it as, yeah. 1 second. Yeah, the flash, MAC flash. It's what you are referring to it.
Now I hear, so if you just go back to the picture a second, I guess as an operator, this is what I sort of want to know. If I had an active backup scenario where I was using DUT as my active to send traffic to R1 and R1 to DUT and MHPE2 as my backup, and then I crush DUT, how fast does it take for my service to come up? That's sort of really what I know is, and then encapsulate it like, then characterize in that manner. How long does the withdrawal take? How long